Do you wear glasses or maybe know someone who needs to take medication for diabetes? Ever wish you could just snap your fingers and change this? What if genetic engineering could solve those and thousands of other common concerns? Before you run away, I understand that this is often a scary topic. I remember watching Dr. Julian Bashir from Star Trek Deep Space Nine when I was a teenager, and his character gave me an early look into some of the ethical dilemmas that genetic engineering could bring into our lives. Before we teleport ourselves into the future of genetically engineered humans, and maybe even real-life X-Men, let's start with, what exactly is genetic engineering? DNA is often called the building blocks of life. Assume you have a good understanding of what all the building blocks can do, and you could swap out the I need glasses block for the eagle eye vision one, or trade the I'm not good at sports blocks for the Olympic athlete blocks. Sounds a bit like a potential real-life cheat code, right? But how do we even do this? Let's start with the game changer in the world of genetic engineering, CRISPR-Cas9. Think of it as the ultimate pair of microscopic scissors. These scissors can target very specific parts of a gene and cut it, allowing scientists to either disable the gene or replace it with a new one. Imagine having a typo in an essay. CRISPR is like your spell check, but for DNA. This technology has revolutionized genetics, enabling unprecedented precision in gene editing. The masterminds behind this invention, Jennifer Doudna and Emmanuel Charpentier, even received the Nobel Prize in Chemistry in 2020 for this extraordinary innovation. What makes CRISPR even more exciting are its real-world applications. Scientists are already using it to create genetically modified crops that are more resilient and have higher yields. Even more mind-blowing, it's paving the way for potential cures to chronic illness like HIV or major life-impacting issues like certain types of blindness, opening doors we only hoped would be possible. Next up is gene therapy. Now this isn't as new as CRISPR, but it's still revolutionary. Through gene therapy we can introduce or alter genetic material within a person's cells to treat or prevent disease. For example, gene therapy offers a glimmer of hope for treating diseases like cystic fibrosis, muscular dystrophy, or Alzheimer's. While still in the experimental stages, the goal is to replace faulty genes with functioning ones, potentially providing a long-term or even permanent cure. Switching gears a bit, let's talk about biohacking. This is where grassroots science often meets genetic engineering. We're talking about ordinary people, not just lab-coated scientists trying their hand at genetic experiments. From the comfort of their own garages or makeshift home labs, biohackers are tinkering with yeast cells to make them glow in the dark, or even experimenting with their own DNA. This term has widened to include people that are trying to find new ways to optimize how their body works outside of genetics, but either way, biohacking also raises a lot of eyebrows. Questions about safety and ethics abound. Should just anyone be allowed to mess around with the building blocks of life? It's a democratization of science, yes, but it also presents risks that we are still grappling with as a society. It's crucial, though, to take a pause here and reflect on the ethical dimensions of all of these innovations. As we move from theory to practice, society must confront questions about the moral, ethical, and social implications of these technologies. What are the boundaries we shouldn't cross? Who gets to decide? Let me know your thoughts on what boundaries we shouldn't cross in the comments below. What might we do in the future with genetic engineering and humanity? First up, let's tackle the age-old quest for the fountain of youth. But forget Ponce de Leon, the real explorers of our age are geneticists like George Church, who are looking to crack the code on aging. The idea is to tinker with specific genes that control the aging process, thereby extending our lifespan significantly. Imagine turning 150 years old and still being in the prime of your life. Slowing or even reversing aging is no longer the stuff of fairy tales, but a field of serious scientific inquiry. Next, let's talk about turning humanity's dials up to 11. We're talking about enhanced physical strength, faster reaction times, higher IQs, the whole 9 yards. While this sounds like the plot of a sci-fi movie, we're rapidly approaching a point where such enhancements could become reality. We've already seen remarkable achievements in the realm of prosthetics and neural interfaces. Combining those with genetic enhancements could result in a new echelon of human capabilities. But what if we could design these capabilities right from birth? Enter the realm of designer babies. While the term has a negative connotation and might sound like something out of a dystopian novel, the reality is that we're getting closer to being able to select specific traits for our children. This isn't just about picking eye or hair color, it's also about eradicating genetic diseases or even enhancing intelligence. However, this leads us into a minefield of ethical questions. A 2018 Pew Research Center survey found that 72% of Americans believe it's appropriate to alter a baby's genes to treat a serious disease, but only 19% think it's okay to boost intelligence. The potential for inequality is massive. Could we end up in a society where the rich can afford better genes for their children? To fuel your imagination further, there's a wild book from 1990 called Man After Man, An Anthropology of the Future by Dougal Dixon. It explores speculative human evolution in ways that are downright bizarre yet highly creative. I remember flipping through this as a child and being blown away by the idea that these strange creature-looking things could still be humans in a way. While it might seem unhinged, it's a fascinating thought experiment in what could happen if we take genetic engineering to its extreme limits. It's also a reminder that the choices we make now will potentially reverberate through future generations. Once a gene is edited that impacts reproductive cells, then it can be passed from parent to child. We're writing the code for humanity's future, quite literally. Now it's time for story time. Nova wakes up precisely at 5:30 a.m., her internal biological clock ticking with the accuracy of an atomic clock. Her smart mirror scans her, confirming perfect blood sugar levels, no signs of stress, and an ideal heart rate. Exiting her home for a walk in the bustling city, Nova's eyes can see wavelengths beyond the current visible spectrum. The radiant heat from people walking their dogs, the ultraviolet scribbles of graffiti on a nearby wall, and even the city's smog transform into vibrant swirls of color. Back in her home office, Nova sits at her desk, which is more like a cockpit of futuristic design and function. As a genetic counselor, she consults with expectant parents via holographic meetings. Today, she guides a couple through a 3D chromosome map, zooming into sections of DNA and annotating potential edits for eradicating hereditary diseases. Lunch is a flash, a nutrient-dense shake designed for cognitive amplification. She quickly returns to her workspace, which features a built-in treadmill. She completes a 5K while skimming through the latest gene therapy research, her body's rapid recovery mechanisms kicking in, bypassing any need for a rest or cooldown. In the evening, she transitions to her art studio, adjacent to her office. Her hands move gracefully across a digital canvas, creating a surreal landscape that blends reality and imagination. Each stroke reveals her heightened dexterity and unparalleled creative vision, rendering each hue and curve with surgical precision. The night is still young for Nova. She accesses a virtual philosophy forum dissecting theories of existentialism and parallel universes as if they were light reading. Complex algorithms and philosophical paradigms bend under the weight of her rapid cognition, solidifying her reputation in the online intellectual community. Finally, she prepares for bed, her mind and body as agile as they were in the morning. Like with so many technological advancements we are making right now, I feel like genetic engineering is something we aren't ready for as a society. I would love to see genetic diseases removed, longer and healthier lives for the next generations, and so much more. But I think right now we need to be fighting to make sure the governments of the world put laws in place early on in hopes that this technology won't further separate the haves from the have-nots. If you are curious about what that might look like, I'm a big fan of the 1997 movie Gattaca with Ethan Hawke, Uma Thurman, and Jude Law. Beyond that, if you want to understand why genetic engineering for our food might be important, I recommend my video on the potential for upcoming nutrient collapse.